Hey guys, Mr. B here. In this video, we're going to be going over the Chapter 10 Geologic Time Review Guide. Alright, so this review guide is set up into sections 10.1, 10.2, 10.3, 10.4, and 10.5. So the questions here are all from the chapter, and we're going to be going through each one. All right, here we go. Number one, these objects form when living things die and are buried by sediments. All right, so this would be, of course, fossils. I'm just going to change the text here to red. Number two, the most common type of fossils are... All right, so there's a lot of different types of fossils. However, the most common types that you typically find are molds and casts. So that's where an object dies, gets buried in sediment, and then, of course, it... gets, not eroded, but it breaks down, and there's a divot or a depression left in the ground from where the organism was. That's a mold. And then water fills it in with minerals and stuff like that, and the minerals harden into rock, and then you get a cast, which is basically a hardened piece of rock that looks like the organism, but obviously it isn't the organism, but it looks like it, right? So that's the most common type of fossil that we usually find. Number three, true or false, fossils commonly form in igneous rocks. That is false. Remember that most fossils form in sedimentary rocks. Igneous rocks, are basically come from magma and lava. So most organisms are not going to form fossils in those types of rocks because those rocks will just destroy the organism, right? They're hot. They'll just incinerate it. So sedimentary rocks are primarily where we find fossils. Number four, true or false, fossils can form when organisms are preserved in substances such as tar, amber, or ice. That is true. The type of fossil that we get here are called preserved remains. That's usually where you have the actual organism's body and it's preserved in ice or tar exactly as it was. Might be a little dehydrated looking, but it's the actual body itself. So number five, true or false, fossils, give me 1 second, sorry. Fossils can be things that give scientists clues about the past activities of an organism. This is also true. So the main type of fossil that does this are trace fossils. Okay, so trace fossils are things like footprints, poop, could be feathers or eggs or things like that, where they give you ideas about what the organism used to do or where it used to live, but it's not a fossil of the organism itself. It's a fossil of something the organism left behind. So that is true. Number six, scientists who study fossils around the world are known as, these are paleontologists. Number seven, the fossil record shows that different groups of organisms have changed over time. This is known as, so this is evolution. The fossil record has shown that organisms on Earth have moved from very simple to very complex over the last, 4.5 billion years, and they've essentially evolved. So, all right, moving on to the second section here on the relative age of rocks. Number eight, according to the law of superposition, younger rocks are layered on the bottom, older rocks are layered on the bottom, younger rocks are layered in the middle, older rocks are layered on the top. So law of superposition, I like to think of this as the law of pancakes, because the oldest, or the oldest pancakes, or the very first ones that were made, are usually put down on the plate first, and then newer, younger pancakes are placed on top, right? So if your parents ever make you pancakes on the weekends or for breakfast, you know that the nice, hot, fresh, young, new pancakes are right on top of the stack. You grab them, and the older ones that have kind of cooled down a little bit, that have been there for a while, the ones on the bottom. So this is going to be B. Older rocks are layered on the bottom. Number nine, the law of superposition is primarily used to find relative age. Okay, so remember that relative age is telling you if something is older or younger than something else. Okay, so the law of superposition is the rock layers. Older rock layers are younger. Older rock layers are on the bottom. Younger rock layers are on the top. But they don't give you ages or numbers. So number 10, these geologic features of igneous rock can also help determine the ages of rocks. So there are a lot of different geologic features that we mentioned in the chapter, but extrusions and intrusions are the main ones. So remember that an extrusion or an intrusion is where you have igneous rock that pushes its way up through sedimentary rock. It's an extrusion if it breaks the surface and pools on the surface. and it's an intrusion if it pushes its way up, but it doesn't break through the surface, so it's still underground. Either way, though, both are igneous rocks, and they can help determine the age of the sedimentary rocks around them, because we can radioactively date the intrusion or extrusion, get an idea of how old it is. Then that can tell us that the sedimentary rocks that are around it are probably either less than that old or older than that, and we'll have a relative rough estimate of numbers, because remember, radioactive dating gives us actual numbers of years. So, all right, number 11, explain what an index fossil is and how it is useful in determining the ages of rock layers. All right, so remember that index fossils are fossils of organisms that used to be around for a relatively short period of time. And they help us to determine the age of rock layers because we can use those fossils. And if we find them in different rock layers, we know that even if those rock layers aren't in the same place, you know, like one's above and one's below, we know that they are the same age because that fossil is found in both. And that organism only lived for a short period of time. So if it's found in both rock layers, they had to have been around at the same time. So let's say that index fossils can help determine the age of rock layers because they are fossils of organisms that were around for a short period of time. And if the fossil is found in multiple rock layers, then those layers had to have been laid down at the same time. Something like that. All right, number 12. Explain what an unconformity is and draw a picture to show what it would look like. Oh, all right, we're going to try to draw a picture here, but let's explain what it is first. So an unconformity is where you have layers of rock, and some of them have been eroded, and then new layers have been laid on top. So an unconformity is where you have maybe like rock layers that kind of go like this, but then the top of them are gone, and there's new layers on top. So it's like there's pieces that are missing. Okay, so we can say an unconformity. An unconformity. There we go. An unconformity is when some rock layers are eroded and new rock layers are laid down on top, creating a gap in the geologic record. All right, we're going to draw a picture of what it looks like. All right, so we're going to try this. Okay, never done this before. Let's go into drawing. Let's go new. And curved connector, scribble. Let's just do scribble. All right, so let's do this. So let's go. I'm going to draw rock layers like this, and then we'll draw some other layers like this, and then we'll draw some other layers on top like this. Okay. So we have this. Okay, so the unconformity is this part right here, okay? Where we have these rock layers, but then it's like they just kind of got erased and then new rock layers got laid on top. So that is our unconformity. Can we color these in? Line color? No. Actions. I don't know if I was going to see if we could fill these in with color, but you know what? Probably good enough. So let's just say save and close. Let's maybe put a text box actually right here. And let's just type in unconformity is here. Okay, so we know like this is the unconformity, is this part like right there. Okay, all right, save and close. Bam, look at that picture. Woo, figured it out, guys. We're good. All right, here we go. Number 13, geologists find absolute age of rocks using radioactive dating. Okay, so this is where they find the absolute age of a rock. Remember that an absolute age is a set number of years. Okay, so absolute age is when you have actual, like a number attached to how old a rock is. Remember that it's not an exact number. Okay, this is a big misconception. Absolute age is usually a time span. So it's like, 100 million years to 250 million years. Like the rock is somewhere in this age. Okay, usually it's an estimate or an approximate. It's never like exact. like this rock is exactly 1,953,127 years old. No. Okay, our dating techniques are not that exact. So it's usually a time range. But either way, absolute age is found using radioactive dating, where they look at half-life. Number 14, the amount of time for 50% of a radioactive element to decay is known as its half-life, right here. Okay, so this one's easy to remember because when 50% of it is gone, half of it is gone. Okay, so we call this a half-life. Number 15, this type of radioactive dating works best for fossils less than 50,000 years old. So remember that there's a lot of different dating techniques, but carbon dating is the one that works well for relatively young things because carbon-14 only has a half-life of about 5,000 years, so it doesn't work well for dating things that are really old. And 50,000 years is relatively young when we're talking about ages of stuff in Earth's history. So, all right, 10.4, number 16, scientists have calculated Earth to be this many years old. About 4.6 billion years old is what we estimate the Earth to be. It is definitely way older than a few million years, and 3.5 billion is kind of close, but 4.6 is what we are looking for. So, number 17, let's try to format this right. This section of time takes about 88% of the geologic time scale. So if we go look back at the geologic time scale, which is in chapter 10, section 4, I think section 4, Precambrian time is the part at the very, very beginning that looks really small, but it's actually like most of the timeline. Okay, so about 88% of geologic time is Precambrian time. And only about 12% is after that, which is most of the things you've ever heard of. All the life forms you've ever heard of, all the major events you've ever heard of happened after Precambrian time. Number 18, select the answer that puts these sections of time in order of longest to shortest. All right, so in the notes, they only talked about eras and periods. Okay, eons are the section of time that's longer than an era, but it wasn't in the notes. So we know that eras are longer than periods. Okay, and then eons are before eras. So we're going from longest to shortest. So we want to have eon, then era, then period. So this is going to be letter D, okay, is this one. Longest is eons, and then eras are second longest, periods are then the shortest. All right, 10.5, number 19. Scientists have hypothesized that Earth got its moon from. So we think that the moon formed from a collision very early in Earth's history. We think it was hit by a planet roughly about the size of Mars. It kind of hit a glancing blow. It blew a bunch of stuff off of the Earth, which then eventually formed the moon. And this comes from the fact that, again, moon rocks are primarily made from the same kind of material that Earth rocks are, at least Earth rocks that are on the surface. If you go deeper down in Earth, you find rocks that have more heavy metals in them, and moon rocks don't have that. So we think that it primarily formed from the Earth. All right, number 20. Which of these physical features did Earth gain first? So it gained its atmosphere first, okay, from volcanic burps and other gases were given off from inside the Earth, as well as comets and stuff. We think laid down some gases, and then after that, there was water vapor in a lot of that gas, which condensed down to form oceans. And then, of course, once you have your oceans, you then have continents, because continents are essentially just giant islands, right? So if you don't have any water, you don't really have continents. And then after that, life came. So, all right, number 21, Earth's oceans are believed to have formed from. So we think that this came from volcano. Well, okay, so there's actually a couple answers here. We could go with A or C. Okay, the oceans didn't form from formation of the moon. It was not leftover remains of the solar system. So heavy rains is essentially where the water, fell from, right? So we think that most of the water vapor was inside the Earth, and that it got released through volcanic eruptions as water vapor because the Earth was too hot for it to be liquid at the time. And comets also, as they hit the Earth, they leave leftover water as well, because comets are primarily made out of ice. And then obviously that water vapor, which is in the air, condensed when the Earth cooled eventually, and it rained. So we can kind of go with A or C here, both of which are kind of correct, I guess. Volcanic and comet activity primarily is where the water vapor came from, but it did rain onto the surface, so that kind of formed the oceans. Just for the sake of simplicity, I'm going to say that it's primarily A, okay, and not C. Heavy rain certainly is where water fell out of the sky, but it's not like where the water came from, right? That's just the result of it going from gas to liquid. So let's say that it's A. All right, number 22. The first life forms that were believed to have been on Earth were single-celled organisms. So you think the very first life forms were like bacteria, single-celled organisms. They were not complex. Jellyfish are pretty complex. Even algae and moss are pretty complex. So single-celled organisms. Number 23, scientists believe that the first life on Earth appeared. So when did the first single-celled organisms appear? We think about 3.5 billion years ago. Okay, this was in the timeline activity that you did. First organisms about 3.5 billion years ago. And number 24, Earth's continents have slowly moved over time due to, this is continental drift. So remember that our crust, which is the surface of the Earth, is broken up into different pieces. And underneath that is the mantle. The mantle is constantly moving, and so the pieces on top also shift with it. This is known as continental drift. All right, we need to shift this down so that we can actually see this picture. All right. Number 25, order these events in Earth's history into a geologic timescale with sequential time, numerical time, and time interval columns. Also, write one sentence describing an event in Earth's history using all three columns of information. All right, so here's what we're going to do. This is an activity we would have done in class, but we didn't. So you're going to learn about it here. So we're going to make a table that is 3 by 1, 2, 3, 4, 5, 6. 3 by 6. Bam, like this. Okay. And so we're going to have in this, so let's hit center and bold. So we're going to have sequential time, numerical time. Oh, actually, sorry. We want to do time interval over here. Time interval, numerical time, and we want to have sequential time. All right. So we're going to do, again, this is something we would have done in class, but we're doing it here. So, all right. So what we're going to do is, in the numerical time, we're going to have number of years. In the sequential time, we're going to have all the events. And in the time interval, we're going to have what time section they happened in. Okay. So numerical time, we're going to have youngest at the top, oldest at the bottom. Okay. So we're going to look at all these things and we're going to put their number of years in here from youngest to oldest. So first bird appeared 251 million years ago. Greatest extinction occurred 251 million years ago. Most diversity of life ever seen, Cambrian explosion, 542 million years ago. Antarctica froze 2.6 million years ago. First ferns were 400 million years ago. All right, so the youngest one here is 2.6 million years ago. Okay, that's the youngest. And that's letter D. The oldest is this one, letter C, 542 million years ago. So 542 million years ago. Okay, we're going to put those in first in that order because we know that that's youngest, oldest. So the youngest one here, this was Antarctica. Antarctica froze. Okay, that was this event, letter D. And this is in the Cenozoic era. That's the time interval. Okay, Cenozoic era. All right, so we're going to cross this off now that we've used it. Text, strike through. Okay. This one, 542 million years ago, this was letter C. So this was Cambrian explosion. Cambrian explosion. During the Paleozoic era. That was the time interval. So Paleozoic era. Okay, so that one is letter C. So first we want to just set it up like this. So we have the oldest event at the bottom, the youngest one at the top, and then we've got all these events in between. Okay. So the next one after 542 was 400 million years ago. So 400 million years ago. The event was first ferns were seen. So first ferns. Time interval was still the Paleozoic era. So that's that one. And then A and B both happened at the same time, 251 million years ago. So let's maybe merge these together. So what we're going to do is we're going to highlight both, right click, hit merge cells. Okay, so it's one. Okay, let's undo that because I want us to have columns. Oh, gotcha. Okay, so we'll highlight these two. Merge those. There we go. Highlight those two. Merge those. Highlight those two. Merge those. That way we still have columns, okay? So we're going to have 251 million years ago for both. And let's hit enter so that we're just going to write this like this. 2 million years ago. Okay? And then we have first bird and greatest max in Permian extinction. So let's go. It probably doesn't really matter the order, but I guess it's probably going to be first bird here. And then the Permian extinction probably happened afterwards because everything died off. And this happened during also, it says here, this happened during the Paleozoic. So the Permian extinction was during the Paleozoic. Oh, and the first word was the Mesozoic. Okay, so we actually want to flip this. So Permian extinction happened first. First bird happened second. The time interval for this one is the Paleozoic era. And then this was the Mesozoic era. Okay, like this. Mesozoic. There we go. All right. So you know what? And this is my bad. We actually probably want to have these as separate things. But whatever. It doesn't matter. It's fine. All right. So here we go. So these both happened at about the same time. But the Permian extinction happened first because it was during the Paleozoic. And then the first birds came afterwards in the Mesozoic era because that's a whole different era. Okay. So here we'll see now that we have oldest events at the bottom, youngest ones at the top. We go from oldest to youngest. And the time intervals go Paleozoic, 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 then Mesozoic, and then Cenozoic. Okay, and the events are in this order. Okay, so this is a timeline. Again, we would have done this in class, but we didn't. So we're going to learn about it here. All right, moving on. Number 26. And let's shift this down. Oh, that image is not coming with. All right, so we're just going to move this down like this. Where did that go? There we go. Okay. Label the following layers from youngest to oldest. Okay. So we're going to have to figure that. I guess we'll just type it down below here. All right. So let's go. We'll go 1, 2, 3, 4, 5, 6. And then this little intrusion here will also label as number 7, I guess. So we'll go oldest. Oh. Oldest. And then down here we'll go youngest. Okay, sorry, youngest to oldest. Sorry, we want to do the opposite. Youngest. There we go. To oldest. Okay, so first thing that is the youngest is probably going to be the one on the top, which is number 6. So layer 6 is youngest. Let's underline these so they stand out a bit more. Maybe bold them too. There we go. Okay. Layer 6 is the youngest. Actually, no, I'm sorry. It's not. It's not the youngest. Here's why. This intrusion cuts through everything, including layer 6. And intrusions, anything that this cuts across, it's younger than everything it cuts across. So actually, this little intrusion is going to be the youngest. So let's say intrusion, or layer 7, whatever you want to call it. And then after the intrusion, then we have layer 6. Then comes layer 5. Then layer 4. Then layer 3, layer 2, and layer 1. Okay, so the oldest layer is layer 1 at the bottom. Then layer 2 is second oldest after that. Then layer 3, then layer 4, then layer 5, then layer 6. And then this intrusion here is going to be the youngest because it cuts across everything, including into layer 6. Okay, so youngest is intrusion, and then all the layers down to the oldest. Something like that. Okay, law of superposition and the law of cross-cutting for that one. All right, I think this is the last question. It is. All right, last question, number 27. Using the above figure on the half-life of uranium, what would be the age of a sample of volcanic ash if it had a percentage of uranium-235 at 35%? All right, so what we're going to do is we're going to find 35% on this graph. We are going on the axis here. We're going to move over until it intercepts with the graph, roughly about here. Then we're going to go down and we're going to estimate what this is. Okay. Now, each one of these lines, I'm pretty sure, is 200 years. So it goes 0, or 200 million years. 0, 200 million, 400 million, 600 million, 800 million, 1,000 million, 1,200 million. So at 35%, go down here. This is roughly 1,100 million years old. Okay, 1,100 million years, roughly. So we will say here that the age of a sample of volcanic ash with volcanic, there we go. In the age of a sample of volcanic ash with 35% to 35 would be approximately, there we go, 1,100 million years old, based on this graph. Okay, that is it. That is the last question. So hopefully that helps you. And as always, if you have any other questions on this, please feel free to reach out. I have no problem helping you in any way that I can. All right, guys, that's it for the Chapter 10 review guide. Up next is your test. So if you need to do some more review, do so. But otherwise, good luck. All right, I will see you in the next video. Bye.